Hello, in this video tutorial I gonna demonstrate you how to calculate the excavation volume for buildings, terrain elements and subtraction solids. In the first step we will calculate the excavation volume for the building in our test project. Before we do so, we will take a closer look at the environment of our project. We deselect the grid and select the 2D view. Here in the 2D view we can see that two different height layers were defined by two height points. The first layer is on a height of 0.0 meters. In the section view, it's this height point. In the 3D view, it's this area. The second height point is on a level of minus 2.80 meters. In the section view, it's this area. And in the 3D view, this area. The gradient which results out of these two height points is visible in the section view. And in the 3D view, it's this area. We select now again the 2D view to zoom into a position with a good overview, and in the next step we will manually calculate the volume of a floor of our building. Therefore we select 2D and Layout, Measure, and measure Polygon with text. We measure along the external walls of the selected floor. This is the first point, the second point, the next point, next point is here, here's a point too, also here, here, and this is the last point. Now the text with the square meters of the measured area is attached to our cursor. We zoom a bit out of the view and we place the text with a left mouse click, for example, here. After it, we press the Escape key. We can see now that the measured surface has an area of 156.42 square meters. Now we have to determine the floor height so that we are able to calculate the volume. Therefore, we make a right mouse click on the current layer and we select Properties. Here at the point Rough Height, we can see that the height of the ground floor is 2.80 meters. We close this dialog. We make a double left mouse click on our text. And now we calculate 156.42 multiplied by 2.80, what results in a volume of 437.98 cubic meters for the ground floor of our project. After it, we confirm with OK, we press the Escape key, and now we have manually calculated the volume of our ground floor with 437.98 cubic meters. Zoom in the 2D view into a position with a good overview. And now we will automatically calculate the excavation of the whole building. Therefore, we select terrain, and excavation. The excavation menu opens and here we select the point building. We can see that at the point selected element, the excavation for the building is 209.85 cubic meters. The volume of the building is 1477.19 cubic meters. At the point project you can see again the total excavation with 209.85 cubic meters. The excavation itself is displayed in red color in the preview window. In our section view, it's this area. Of course, you can also tilt, shift and zoom the preview window. Also, you can disable the terrain solid. After it, we confirm with OK. This was now the first method to calculate the excavation volume. In the next step, I will demonstrate you how we can calculate the excavation volume for a terrain element. Before we can calculate the excavation volume of a terrain element, we have to create a terrain element. Therefore, we will define here in this area next to our project a path. We turn the 3D view a little bit to the side, and here in this area we will create the path. We turn it back again and we zoom a bit into the view. Now we select the 2D view, we press and hold the Ctrl key and we select the environment. The path which should be created next to the building will have a width of 1.5 meters. The reference point of the path is in the middle. That's why we will use the support of guidelines. We press the shortcut P for the function numeric parallel guideline. We press the right mouse button and select Properties. We select Appearance, we choose another color for the guideline, for example yellow, and we confirm with OK, OK and OK. We enter the first guideline from here into this direction in a distance of 0.75 meters and we confirm with OK. The next guideline from this line in this direction, also 0.75 meters, we press Enter. One more guideline from this line into this direction in a distance of 9.50 meters. And the last guideline is exact on this line in a distance of 0 meters. We press Escape. And now we have finished defined all the guidelines we need to insert the path. Now we create the path. We select Terrain, Terrain Elements, Path, and insert with Polygon. We press the right mouse button and we select Properties. Now we define the properties of the path. For the width we enter for example 1.50 meters. The height above the terrain is already correct defined, and for the excavation deep we enter 0.10 meters. After it we confirm with OK. Now we enter the path. This is the first point. That's the second, And this is the third and last point. After it, we press the right mouse button and we select Complete. The path was successfully created and we take a closer look in the 3D view. Everything seems alright so far, and now we will take a look at the excavation volume. Therefore, we select Excavation and we click on Terrain Elements. Here we have again a preview window where we can tilt, shift and zoom the view, and we can also disable the terrain solid. Our path is already marked in red color in the preview window. The excavation of the terrain element is 3.15 cubic meters. The subtraction volume is 3.46 cubic meters and the area is 32.11 cubic meters. The total excavation is 3.15 cubic meters. Also, we can take a look at the analysis. Here you can find a list of all the excavations. If we want to use this list, we can click on Copy Analysis to Clipboard. After it, we confirm with OK. In the next and final step of this video tutorial, we will calculate the excavation volume of a subtraction solid. Also, at the excavation calculation for a subtraction solid, we have to create the subtraction solid before we can continue with the calculation. The subtraction solid will be created in this area. Here you can also see this area in the 2D view. In the upper area there is a door which is hidden right now by the terrain, and with the subtraction solid we will give access to it. The width of the subtraction solid from the wall should be 1 meter. Therefore, we use again the help of guidelines. We press the shortcut P for the function numeric parallel guideline, right mouse button, Properties, we change the color, for example to blue, and we confirm with OK, OK and OK. We enter the guideline from this line into this direction in a distance of 1 meter. After it, we press Escape. Now we select the 3D view, we press and hold Ctrl and we select the environment. We click on Construction, Subtraction Solid, Cube and Insert with Rectangle. We are now asked to select a surface in 3D for plane definition. In our case, that's the surface with minus 2.80 meters. That's the surface in the 3D view. It gets marked in red and we confirm with a left mouse click. After it, we select the 2D view, we press the right mouse button and we select Properties. We click on Cube, and here at the point parameter we can define the width, the depth and the height of the cube. The width is already correctly defined. For the depth we enter 10 meters and for the height 2.80 meters. The height difference between the selected surface in the 3D view and the second height line, which is defined with 0.0 meters, is 2.80 meters. So that's correct and we can confirm with OK. We enter now the first point of the subtraction solid here, and that's the second point. After it, we take a look at the subtraction solid in the 3D view. We zoom a bit into the view, and as you can see now, because of the subtraction solid, the access to the door is now possible. We continue with the calculation of the excavation volume, therefore we select Terrain and Excavation. Here we select now at Excavation the subtraction solid. In the preview window, the affected area is marked red again, and at the point selected element we can see that the excavation is 13.11 cubic meters and the subtraction volume is 28 cubic meters. We click on OK. And now we have finally reached the end of our video tutorial. Thanks for watching. For more tutorials, visit our website cadvilla.com.